Hi students, we are discussing kinematics. We discussed equations of motion when a body moves in a straight line with uniform acceleration. Now in today's class we will do certain problems based on that. Okay. First problem. A driver takes 0.20 seconds to apply brakes. After he sees a need for it. This is called the reaction time. Of the driver. If he is driving a car at a speed 54 kilometers per hour and the brakes cause a deceleration of 6 meter second to the power minus 2. Find the distance traveled by the car after he sees the need to put the brakes on. So this is the problem. A driver takes 0.2 seconds to apply brakes after he sees a need for it. So driver wants to apply the brakes. After getting the need for applying the brakes, it takes 0.20 seconds. This is called reaction time. Seeing and he is going to apply the brakes. So that during that time the car travels a certain distance. So before applying the brakes. So the distance traveled by the car before applying the brakes. So solution. Distance traveled by the car before applying the brakes. Before apply brakes. After he wants to apply the brakes, before applying the brakes, during the reaction time, the car travels a distance. S is equal to velocity into time. Okay? So because the car is traveling with uniform speed before applying the brakes. So distance is equal to velocity into time. So velocity is 54 kilometers per hour, 54 kmph, you convert into meters per second. So you multiply with 5 by 18. So to convert kilometers per hour into meters per second, you multiply with 5 by 18. So it converts into meters per second. So 18 fours, 18 threes. So 18 threes, 24, 54. So 18 threes, 54, 3 into 5, 15 meters per second. So 15 into time. In how much time? 0.2 seconds. So the second get cancelled. So how much distance he travels during that time? 15 into 0.2. That is 15 into 0.2, 3 meters. So before applying the brakes, he travels 3 meters. 15 into 0.2. 15 into 0.2, how much? 30. 15 twos are 30. This is, so 3 meters. Okay, 3 meters. And so after applying the brakes, the car starts deaccelerating. So finally the car comes to rest. So final velocity is, the initial velocity is, before applying the brakes, 15 meters per second. 15 meters per second. After finally the car comes to rest with what deacceleration? 6. That is 6 meter second to the power minus 2. Deacceleration means negative acceleration. So the speed of the car gradually decreases, finally comes to rest. So how much distance traveled during this one? During this time. So it will take how much distance traveled. So which formula we are going to apply? So apply after applying the brakes. After applying the brakes. After brakes applied. Brakes applied. Finally comes to rest. So apply v square minus u square is equal to 2as. So what is v? 0. U square, 15 square, 225, 2a. A is 6. Yes, we want. Yes. So distance traveled is minus get cancelled, 225. So this is 15 into 15 by minus get cancelled, 2 into 6. So 3 2s, 3 5s. So this is 15 into 5, 75 by 4. 75 by 4. So how much? This one, 4 ones are 4. 35. 4 8s. 4 8s are 32. 30 again. So 4 7s are 28 to 5. So 18.75 meters. So total distance traveled by the car before coming to rest. So total distance. So total distance before comes to rest is 3 meters plus 18.75 meters. So that is 18.75 plus 3, 21.75 meters. So the car finally comes to rest after applying the brakes. After sees he needs the applying the brakes. So he needs for the brake. So after needing, the car travels a distance 21.75 meters and finally comes to rest, so that we can avoid collision. Okay, next problem. సార్ అజయ్ గారు, హర్ష గారు, నెక్స్ట్ ప్రాబ్లం. ఓకే, ఏ passenger is standing d distance away from a bus. The bus begins to move. With constant acceleration. A. To catch the bus, the passenger runs. With a constant speed u towards the bus. What must be the minimum speed of the passenger? So that passenger speed of the passenger, so that he may catch the bus. So this is the problem. We want minimum speed of the passenger, so that he should catch the bus. Where is the bus? A passenger standing at a distance d away from the bus. Let it be, B is the position of the bus, P be the position of the passenger, where he is at a distance, passenger standing at a distance d from the bus. Okay, passenger standing here. at a distance d away from the bus starts. So bus starts, initial velocity 0, moves with a constant acceleration a. So this person wants to catch the bus. So what is the minimum speed of the passenger? The bus is accelerating. So where he catches the bus, at what time he catches the bus, we don't know. So let at the position B dash, the passenger catches the bus after t seconds. So my assumption is solution. Assume passenger catch the bus at the position B dash. At the position B dash, when the bus is B dash. After t seconds. So I assumed this. Okay. So this distance, let it be d1. So during that time, bus travels a distance d1. So how much bus distance traveled? So for bus is equal to how much distance traveled? d1. Apply for bus, you apply s is equal to ut plus half at square. That is second equation of motion. So d is d1, initial velocity of the bus is 0 into t, half a t square. So that distance, let it be equation 1. So in the same time, passenger has to travel a distance d plus d1 distance in the time interval. So for passenger has to travel how much distance? Has to travel d plus d1 distance with the speed u. Distance traveled is speed into time in the same time. So this is the distance traveled by this speed. So in order to catch the bus, the speed of the bus ut should be greater than equal to distance traveled in the time. So for passenger, distance is equal to, this is uniform motion. Passenger has uniform motion because he has uniform speed. So for bus it is accelerated motion, for passenger it is uniform speed. So uniform motion, distance is equal to speed into time. So to catch the bus, ut should be greater than or equal to d plus d1. Okay. This ut should be greater than equal to d plus d1. What is d1? Half a t square. So I will write here. Okay. ut greater than, so that is half a t square. I will multiply this one, a t square minus 2 ut plus d should be greater than or equal to 0. Okay. So this is the quadratic equation. So quadratic equation, the solutions, t has two real roots. So what is the solution? This is quadratic in t. A is constant, u is the speed of the bus. So what is quadratic equation solutions for t? So what is t? We have minus b, that is 2u minus b plus or minus square root of b square minus 4ac. I am using that formula. So what is b here? B is 2u, that is 4u square b square minus 4ac, that is 4a into c. C is d. So 4ad, that is okay. This is also 2d. This is also 2d. Here multiply with 2. 8 square minus 2ut. Bring this side. It should be, you bring this side. Minus becomes plus. This is plus. This should be less than. So you bring this side. You will become, it should be greater than 0. Minus plus. Okay. So it should be greater than 0. And here b square 2u square minus 2ad, b square minus 4ac. 4ac means here 2, 8. So 8ad by 2a. So the t should have real roots. For real roots, to catch the bus, t should have real roots. So for t to be real, the discriminant should be greater than 0. So t to be real roots, disk should be greater than or equal to 0. Okay. So that is 4u square minus 8ad should be greater than 0. That is u square greater than 2ad. So u should be greater than or equal to 2ad. So this is the condition. The speed of the bus, speed of the passenger u, it should be greater than 2at to catch this bus. That is the required equation. Okay, check once, take this. Next problem. A car accelerates from rest at a constant rate alpha for some time. After which it deaccelerates at a constant rate beta to come to rest. If total time elapsed is T A, evaluate A. First one, maximum velocity attained and B, total distance traveled. So these are the two questions. Okay. So this is the sum. Next sum, third sum. A car accelerates from rest at constant rate for some time. How much time it accelerates we don't know, let it be T1. Then it attains maximum speed. A car starts from rest. Solution. So starts from rest U0. Constant rate accelerates. Acceleration is alpha for some time. How much time we don't know, let it be T1. So from we know that it attains a maximum speed V. Let V be the speed. So acceleration we have A is equal to change in velocity V minus U by T, T1. Okay. V is the maximum speed attained. U is the initial speed 0. So I am applying this formula V minus 0, A is equal to alpha. Apply this formula, acceleration formula. Alpha A is alpha V, maximum speed attained, let it be V, initial velocity 0 by T1. So you call it as equation 1. Now next, after attaining maximum accelerating, it starts deaccelerating at constant rate beta. So again it starts accelerating V to 0. How much time it deaccelerates we don't know, let it be T2 seconds. So you define T2. Again you write beta is equal to, apply same formula here. Beta is equal to 0 minus V by time, let it be T2. This is the deacceleration. That is minus beta. So this minus get cancelled. We'll get beta is equal to V by T2. So from this, what is, we want a maximum speed. Total time elapsed. T1 is V by alpha. You call it as equation 1. Both are same. T2 is equal to V by beta. Call it as equation 2. Okay. Total time elapsed. Total time is T. T1 plus T2. Okay. Total time elapsed. T1 plus T2. So T is equal to, what is T1 from equation 1? V by alpha. What is T2? V by beta. So you take LCM and you write for V. V into 1 by alpha plus 1 by beta. That is T. So what is V? We want maximum speed attained. V is equal to, you take LCM here, alpha beta by alpha beta of T. So this is the required answer. We want maximum speed in terms of alpha, beta and t, where t is total time elapsed. The next one is, we want, this is the answer for A. This is the answer for A. Now we have to answer for B. What is that? Total distance traveled in a time t seconds. So in the first second, how much distance traveled? In first half, it travels a distance s1. So total distance traveled is s1 plus s2 during accelerated t1 seconds, during accelerated t2 seconds. So total distance traveled. S1 is, we can write it as, total distance is, we can write it as average velocity into time. Instead of this, average velocity, otherwise you write s1 plus s2. What is s1? S1 is half at square, because initial velocity is 0. So half a alpha t1 square. T1 square is v square by alpha square. Alpha square. So that is v square by alpha square. That is plus s2. S2 is from final velocity v2, that is vt, maximum velocity vt, vt2 minus half beta t2 square, that is half alpha, half, that is v square by alpha, 2 alpha, 1 alpha get cancelled, plus vt2, v into, what is t2? T2 is v by beta, that is v square by beta. Here v plus, here minus this first term, second term is over, third term minus half b t2 square. What is t2? V square by beta into beta square. So 1 beta get cancelled, v square by beta. So this will get v square, you take it as common, v square by 2, you will get 1 by alpha plus 1 by beta, that is alpha plus beta by alpha beta half into v square. Okay, this is the total distance traveled. Okay, so the same we can write it as in another way, that is average velocity into time. We can write average velocity into time. What is average velocity? Minimum plus maximum by 2. This we can also write it as v alpha beta by alpha plus beta. This is v is, we want alpha beta by alpha plus beta into t. So I take LCM, alpha beta here, half of alpha plus beta into v square. Average velocity into time. Average velocity is half of, this is minus, we will get s1 plus s2. So what we got here, half alpha plus beta this one, velocity square, instead of v we can write this one also, we can express in terms of t. So s is equal to half of alpha beta by alpha beta v square. Instead of this alpha beta, one v get cancelled, so you will get half of alpha beta by alpha plus beta, alpha beta square, one get cancelled one time into t square. So instead of v, if you write, substitute this value, you will get this in terms of t. This is in terms of maximum speed. So this is the required answer. Average distance traveled during the total time t is half of alpha beta by alpha beta into t square. The same thing we can written in another way. That is average velocity into time. So the same thing we can do here. S is equal to total average velocity into time. Average velocity into time. Average velocity is starting 0, it attains a maximum speed v and uniformly decreased again to 0. So average is maximum plus minimum by 2. Minimum is 0, maximum is v by 2. Average velocity into time. So S is equal to v by 2 into t. But what is v? S is equal to half. What is v? We got it as alpha beta by alpha plus beta into t. In t into t, t square. Thus also we can get this one. So instead of v, since v is equal to alpha beta by alpha plus beta into t, we got earlier this one. So this is the solution for this problem. The same problem we can explain with the help of graphs. Say you draw a graph, vt graph, starting 0, for some time it accelerates alpha. So this velocity is v, it attains maximum speed v, starting velocity 0. So here acceleration is alpha, it accelerates for some time. How much time? t1 seconds. Then it starts deaccelerating. That is, it has a negative slope. That is t2 seconds. So t2 seconds. So this deacceleration is beta. So this acceleration is alpha. Here the deacceleration is beta. So this is the graph. This is uniform speed graph. Positive slope, vt graph alpha, and negative slope. That is, it shows deacceleration. So the same problem we can solve by using this vt graphs. Say vt graphs. What is, we want average velocity. See, maximum velocity attended by it. Maximum velocity attended by it, we got it as v is equal to, from graph we have the slope of vt curve. Slope of vt graph gives acceleration alpha, that is v by t1. From this, t1 is equal to v by alpha. V by alpha. What is slope of vt graph? Beta, deacceleration. V by minus v by t2, that is minus beta. That gives t2 is equal to v by beta. By solving these two equations, as earlierly we did, from equation t is equal to t1 plus t2, we got maximum speed v 1 by alpha plus 1 by beta. That is, we got it as v is equal to V is equal to alpha beta by alpha plus beta of t. So we got from this one same result by using drawing Vt graph. What is the concept here? The slope of Vt graph gives acceleration. Based on that, now I want displacement for this. I want solve this one with the help of graph. The same thing. How? Area of Vt curve, say B problem. Area of Vt graph gives dash displacement, total displacement. So S is equal to total displacement is equal to area of this area A1, let it be A2. So total area is, I will write it as total time is t, half into base into height. So total area of that curve, half into base t into height v, half into base into height area, that is half. V is alpha beta by alpha plus beta into t square. Yes, the same result we got from graph. Okay, this is graphical solution. We can do like this also. Take this one. Next problem. Draw displacement time and acceleration time graphs for the given Vt graph, for the given velocity time graph. So Vt curve is given, we want displacement time graph, acceleration time graph. What is given? Velocity time graph is given. So I will draw this one. The question, velocity time curve. So on x-axis time is taken. So for 10, this is velocity 10 units. This is 5 units. Then 10, 5 to 10 seconds. Then deaccelerates like this. So this is 12 seconds. T is the time. Okay. This is uniform speed 10 meter second inverse. So unit is velocity meter second inverse. This time is seconds. So this is the graph. Okay. Now this is the graph. Now see this graph. Draw displacement time, acceleration time graphs for the given velocity time graph. Velocity time graph is given. You have to draw displacement time, acceleration time graph, AT and ST graphs. Okay, let us see how such problems we can solve. First you study the nature of the motion. Okay, first you study the nature of the motion. How? See, first during time 0 to 5 seconds. So time interval 0 to 5 seconds, up to 5 seconds. Okay, what is the nature of the motion? It is uniform motion, increasing slope, positive increasing slope. So velocity gradually increases. So the slope of VT curve gives acceleration. So the first one is during 0 to 5 seconds. What is acceleration? The slope of VT curve gives acceleration. Slope of VT curve gives what? Acceleration. We know this. Okay. So what is acceleration? A is equal to slope is tan theta. Tan theta is y coordinate by x coordinate. That is 10 by 5. That is 2 meter second to the power minus 2. So acceleration. What is the distance traveled during this time? So area of VT curve. Area of VT curve under x-axis gives displacement. So we know this displacement. So you find the displacement during this second. S is equal to displacement area of VT curve. What is the area of this one? Let it be A1. A1 is how much? Half into base into height. Base is 5, height is 10. 10 square, 100. So this is 50 into 5. So 5 into 50. That is 5 is 20. 250 meters. So during the 5 seconds, the body accelerates, uniform acceleration. Acceleration is 2. It travels a distance 250 meters. Next. So we got S, we got A. So because we want AST graphs. Next one is during 5 to 10. So when T is greater than 5, less than 10 seconds, equal to 10. So what happens? Body during this interval, the shape of the curve is parallel to x-axis. What does it mean? The body moves with uniform speed. So body or particle during this interval, particle moves, particle has uniform motion. Uniform motion, that is uniform speed. Then distance traveled is SV into T. That is 10 into velocity is 10. How much time? 5 seconds. So it travels 50 meters during that 5 seconds. It travels 50 meters. What is the acceleration during this time interval? 0. What is acceleration? Since the graph is parallel to x-axis, uniform speed, uniform motion, so acceleration is 0 or slope is 0. So acceleration is 0. Next, during interval 10 to 10 greater than T greater than less than 12 seconds, less than or equal to 12 seconds. So what happens? The body deaccelerates. So it has a negative slope. So velocity gradually decreases from 10 to 0 during interval 10 to 12. So what is its acceleration? A is equal to slope of VT curve. So it has a negative slope, that is minus 10 by 2. 10 by 2 seconds, that is minus 5 meters second to the power minus 2. The next one is, I want displacement S is equal to during these 2 seconds. So I am applying area. Area is, this is A2. This area we can write it as A2, or this is A3. This is A2. What is A2 here? A2 is 50, or we can write area of this 10 into 5, 50. We can do like that also. So here displacement is A3. S is A3. Area of VT curve, half into base into height. Half into base is 2 into height. Height is 10. So 2 get cancelled. You will get 10 meters. So during this it travels 10 meters. During these 2 seconds it travels 10 meters. So this is the data we have. Acceleration, displacement. Acceleration, displacement. Acceleration, displacement. During these intervals we have the data. After getting the data, you try to draw the graphs. The first graph is, we want a displacement time graph. See how I am drawing. Displacement time graph. I am drawing here. Displacement versus time. During this interval, during this interval 0 to 5 seconds, body accelerates. So it is uniform accelerated motion. So its shape is ST, shape of the ST curve is parabola. Parabola, positive acceleration, it is with increasing slope. So the shape of the curve is parabola with increasing slope. So with increasing slope like this, up to 5 seconds. So this is the ST graph. So it reaches how much distance here? Displacement 250 meters. Okay. Then this is increasing slope. Then 5 to 10 seconds the body has uniform motion. So the shape of the ST curve is straight line, passing through straight line. How much time? During 10 seconds it will be like this, up to 10 seconds. So this is interval 5, this is 10 seconds. So the graph is straight line like this. Then up to how much distance it travel? 50. So the displacement is 50. So 250 plus 50, here is 300. 250 plus 50, 300 meters. So ST graph. Then it deaccelerates. Deaccelerates means shape of ST curve is parabola with decreasing slope. What is decreasing slope? How it is? So during this 10 seconds, decreasing slope is, I need a space here. So decreasing slope, how it will be? Like this. So I want to rub this one. Okay. So with a decreasing slope like this, decreasing slope. Okay, this is parabola shape. This is decreasing slope, this is increasing slope. So still it travels 10 meters. So finally this coordinate becomes 310. Here 300, further 10 meters it travels. Okay. So this is the shape of ST curve. What is this? ST graph. 0 to 5, parabola, increasing slope, 5 to 10, straight line, uniform motion, 10 to 12, deaccelerated motion. ST graph is parabola with decreasing slope. Okay. one more graph is there. What is that? Acceleration time graph. Okay. So I will draw here only. I will draw here only. Okay. See, I will continue this graph. So what graph I want? Acceleration versus time. So this is 5 seconds. You take acceleration on y-axis, time. So it has uniform acceleration. So during 5 seconds, it has positive acceleration. How much? 2. So uniform means straight line, parallel to x-axis. The shape of the AT car is a straight line. Body moves with a uniform speed. Then 5 to 10 seconds, its acceleration is 0. So it is like this. Then 5 to 12 seconds, it has negative acceleration. How much? 2. Sorry, 5. It has negative acceleration. This is 2 magnitude. Here it is 5. So you should represent more value. So this is -5. This is origin. So what is this graph? AT graph. AT graph. So I draw VT graph is given. I draw corresponding ST graph and AT graphs. AT graph is 0 to 5 seconds. It is parallel to x-axis, having acceleration to uniform motion, uniform accelerated motion. Then 5 to 10 seconds, it has acceleration is 0. 10 to 12 seconds, it has a negative acceleration -5 meters per second square. So this is the corresponding graphs. This is the answer for this question. What is the question here? VT graph is given. Then we want asked what is, which one is? We have to draw AT graph, ST graph and AT graph. That is the problem. VT graph is given. We draw ST graph and AT graphs. Clear? Take this.